What is up, Math 7? Mr. Uy here with SBAC Prep Part 2. So today what you're going to be doing is you're going to be listening to this playback video while taking some decent notes on that piece of paper and guided notes that I handed out to you before you started watching this video. So make sure you pause whenever you need to, and make sure you save your questions for when we switch to the next groups working on their city projects, so that I can answer them for you if you have any. So prepare yourself, make sure you've got a writing utensil, and let's get to it. So the agenda for today is pretty simple. The two things that I'm pairing together right now is going to be the SBAC whole class activity and the SBAC practice. So these are the notes that you're going to be taking, the practice. And the whole class activity we're going to do in parts. So half of you are going to be working on the actual city project, while the other half is going to be doing the ed puzzle of the SBAC that you're currently listening to. You should have some project work time today, even though today's a short period. You should get a few minutes definitely to either touch base with me with regards to where you are on the project currently, and to get some work time and organization time to further your project. So let's keep on going. Are that you gotta make sure that you take your time, because they give you plenty of it. Even if you are confused about a question, skip it and come back to it later so that you have some time to sort of let it marinate and see what you know about it. Also, make sure you definitely understand what the question is trying to ask you before you try and attack it, because sometimes they ask you questions in a very sort of awkward way, and you might not necessarily know what they're trying to ask you just from your first read through. So it's definitely a benefit to take your time through it and follow the strategies. And again, all I can ask you this year on this test is just try your best like you always do, and you will do fine. So let's keep on going and make sure we get prepared for the. Now, if you recall, the SBAC practice strategy that we are going to employ comes in 4 different questions here. And the 4 questions to ask yourself for every specific question you might encounter is: number 1, what are the keywords? Number 2, what are the math concepts that I know connect to this? Number 3 is, what is the problem actually asking me to do? And last but not least, what do I know to do the problem? So let's keep on using this strategy for the next set of questions that we have here, so that we can be successful next week when we encounter the test. All right, so here is problem number 11, and we're going to ask ourselves the first question as we read through it. A bag contains 16 marbles, and there are 5 blue, 9 yellow, and 2 red marbles. 1 marble is selected at random. It says determine whether each statement correctly describes the likelihood of an event based on the given bag of marbles. Select true or false for each statement. So I'm going to box some keywords here that I see. One of them being random, the second one's being likelihood, and the third one being the true or false. So what these keywords tell me is what I'm going to be doing is I'm going to be pretending to select things at random and determining how likely a specific event is in me pulling out one of those marbles. So using sort of my critical thinking skills here, the first thing that I need to assess whether it's true or false is the statement number 1. So statement number 1 says, it is impossible that a green marble will be selected. Now, if you look up at the top, what you should notice is that there is one color missing from all of the different marbles in this bag, and that is the color green. So it's definitely a true statement that it is impossible to get a green marble, because there aren't even any green marbles in the bag. Next one, it says it's unlikely that a yellow marble will be selected. Now this, we sort of need to think about what probability means, and all probability means here is the total amount of things that we have, and on top here is what we want. So this is how we find the probability of drawing a specific color from this bag. So in this case, we've got 9 yellow out of a grand total of 5 plus 9 plus 2, which gives me 16. So we've got about 9 out of 16 that are yellow. Now, this is not an unlikely event, because guess what? there's way more yellow marbles than any other marbles in the bag. So this is a false statement because we're likely going to draw a yellow marble because there's more of them in the bag. Next one says it is certain that a blue marble will be selected. Now, we can't guarantee that whatever we select is going to be a blue marble because there's only 5 of those blue marbles in the bag, so this has to be a false statement. Last statement here says it is unlikely that a red marble will be selected. Unlikely means that it's probably not going to happen, and using our probability formula up top, we can see that there are 2 red marbles out of the entire 16 that are in the bag, which is a pretty low chance for selection. So it's a very unlikely chance, which means that this is a true statement. So although this problem looks super complicated and might seem kind of daunting at first, all you really have to do is read your way through it. Let's take a look at the next one. Alright, so this problem says that David goes into a candy store with $5. He buys 9 peppermints for 15 cents each and some sour candies. Each sour candy costs 25 cents. Now what it's asking us to find is the maximum number of sour candies David can buy with the money he has left over here. So let's think our way through this problem, and let's start with the important information here. Now I know that the word maximum pops out to me. What we're looking to find is we're looking to find how many sour candies he can buy with the money he has left over. So the important pieces of information is that he starts with $5. He's already bought 9 peppermints for 15 cents a pop, and we know that sour candy costs 25 cents a pop. So first thing I need to figure out is how much he spent already. So if he buys 9 peppermints at 15 cents, all I need to do is a quick multiplication of 15 cents times the 9 peppermints that he has. Now once you long multiply, what you should get is he spent $1.35. Now with this information, what I can figure out is how much money he has left over. So again, once I know he has $1.35 that he spent, I take that original $5 and I subtract from it $1.35. Now once I do this, doing a little bit of subtraction here, so 4, this would be 9, and this would be 10 here. I get 5, I get 6, and I get 3. I have a grand total of 365 left. So now what I need to ask myself is how many of these sour candies can I actually purchase with this amount? So since they cost 25 cents a piece, all I need to think about is how many quarters I can actually put into this. So at most, I can spend $3.50 worth of quarters. Now think about how many quarters that would be. So for every dollar there's 4 quarters, and then the 50 cents gives me the extra 2, which would give me a grand total of 14 quarters that I can spend, which would also equate to how many sour candies I can purchase. So again, this problem isn't very crazy mathematically, but just setting it up and making sure that you understand how you're setting up each step is massively important. Big tip for this question is if they do not provide you a calculator, I would set up this problem on the scratch paper that they give you, wait for a problem that has a calculator button on it, and do these calculations and come back and make sure you enter in this answer. So definitely a solid calculator question once. So here's another purchasing question. Sarah buys a sweater at a department store. The sweater costs 30 bucks. The store is having a 25% off sale on everything in the store. It says enter the amount of money in dollars Sarah saves from the sale. Do not consider the sales tax. So the important things that we see in here, the keywords that pop out to me, is money and sale. So what I know that I'm looking for in this problem is I'm looking for how much money she actually saved from this sale. So if I were to try and find out how much she saved, since it's 25% off, all I know is that she spent $30 and I want to find 25% of that. So how I do that is nothing more, nothing less than just a multiplication problem. So I take 30 and I multiply it by 25%, which is 0.25. Now once I figure out what 0.25 of 30 would be, that would be what she saved on this sweater. So do that calculation real quick on a calculator, or you can long multiply like I'm going to do right now. So 5 times 0 gives me 0 here, 3 times 5 gives me 15, 0 in the placeholder, 2 times 0 gives me 0, 3 times 2 gives me 6. Add these two things together and I get 750. So this would be my savings, my total savings. And if you did this on a calculator again, this is exactly what you would get. So this is how much she saved, nothing more, nothing less than a simple multiplication problem. All right, so here is our first proportion problem. It says an electrician is hired to install outdoor lighting. The electrician claims that the relationship between the number of hours worked and the total work fee is proportional. The fee for 5 hours of work is $225. Select all combinations of values for the electrician's work hours and total work fee that support the claim that the relationship between the two values is proportional. So there are a few words here that pop out significantly to me in this problem. So when we dissect it, the words that should pop out to you are these words proportional, and in terms of their directions here, this word all. Now, proportional means nothing more, nothing less than just a fraction that we can produce from the information that we're given. So the information that we're given here is that for 5 hours of work, this dude charged $225. So using the word proportional, I know that I can create a proportion by doing the following. Taking one of the numbers, 225, and dividing it by the second number, 5. Now what this gives me is the amount of money that he has paid in 5 hours. Now here's the cool thing that I can do with every single proportion. I can carry out the division to give myself something called the unit rate, and we covered this earlier in the year. So if I do 225 divided by 5 on my calculator or do some long division in my head, I should get $45 for every 1 hour worked. Now this is an important key here. This is sort of the key to give us our answer, because since we're going to have to select all the combinations that make sense, we need to verify in all of these scenarios which ones are the true statements, given that he gets paid $45 an hour. So once we go through these, let's see if we can determine which ones are true or which ones are false. So 6 hours and $270. Let's see if this fits our pattern. If I know he worked 6 hours at $45 an hour, all I need to do is multiply 45 times 6 to verify whether or not this is a true statement. So 45 times 6, so 5 times 6 gives me 30. 4 times 6 gives me 24. And plus that 3 on top gives me 27. So this checks out. At $45 an hour, at 6 hours, he would get paid $270. So that makes sense. Boom. I would do the same thing all the way down in order to verify whether or not any of the other ones were true. So big idea here is that you need your unit rate in order to give you the information necessary to verify all the combinations that would work. So you'd go through each one here and make sure that you were able to multiply and verify the actual numerical values you'd get paid. And that is your first proportion problem. Next problem here, looks like we've got a scale image of two triangles. So it says that figure A is a scale image of figure B as shown. The scale that maps figure A onto figure B is 1 to 7 1/4. So first essential piece of information that I'm going to circle nice and big here is this scale factor. Now, scale factors are super important in problems like this because it's sort of the key to unlocking what the relationship is between the little guy and the big guy here. So what this statement says is that for every 1 unit in the small, I know that it actually represents 7 1/4 of the units in real big units. So if I'm given the small units, which is 3, and I want to try and find the big side, which is x, so what the problem's asking me for, all I need to do is use that 7 1/4 to multiply. Because for every one of those units, I know that there's 7 1/4 big units that should scale to it. So basically, this problem boils down to that small side, 3, times 7 1/4. Now this might look crazy to multiply, but when you multiply a whole number times a mixed number, you just multiply the two regular numbers together first, and leave the fraction alone. So 3 times 7 gives me 21, and the fourth is at the end for my final answer. Now, cool thing about this test is it accepts mixed numbers and or improper fractions, so you can convert it to an improper fraction if you want, but this answer is completely acceptable. So 21 and a fourth would be my final answer here. All right, so next problem here shows us one of these find the incorrect step types of problems, and you'll probably see these ones on the tests for sure. So this one says Lisa wrote the expression and she simplified the expression using those steps that you see in front of you here. Now, it says that Lisa says that 3 plus 6x minus that 2 parentheses x plus 1 plus 5 is equal to x plus 6. Lisa's statement is incorrect, so it tells us already that she made a mistake. So what we need to find is we need to find where she made a mistake and what the correct expression for that step would be. Now, the biggest thing here mathematics-wise is the fact that all we're doing is simplifying an expression. So what we should look for whenever we look at simplified expression, especially when we have these steps provided for us, is we need to see what changed. So if we see the original equation here, what we should see here in green is that this portion of the expression didn't change between any of the steps. So that looks good, because if we make no changes to anything, there's no way we can make mistakes to anything. So what I'm going to look at is I'm going to look at this first portion here, this 3 plus 6x portion here. Now look at how they changed it. They changed 3, whoops, let me use a different color here. They changed this first expression, 3 plus 6x in this initial step here, and they changed it somehow to 3 parentheses 1 plus x. Now, one of the things that you should notice here is that if I were to take a 3 out of this original expression, that 3 would be on the outside of a parentheses for sure. But we know that parentheses means to distribute and to multiply. So if I take that 3 out and I multiply it by 1, that would give me my original 3, which checks out. But what's fishy here is that if I took this 3 and I multiplied it by that x, I would not get my original 6x. I'd get 3x. So what's missing here is this 2x. Because now, once I distribute, what I should be able to see is that I'm back to that original equation. So remember that when we simplify, we need to make sure that each and every single step makes sense in the process. So in this case, the first step was the one that was incorrect. And how it should be written is in step 1, and our answer is A here. Now, using process of elimination, we should notice that we can eliminate C and D because it doesn't even talk about step number 1. So even if you did not know how to take out this 3 from the parentheses, you still have a very good shot of getting this question correct with process of elimination. All right, so next problem here is a graph problem. And again, this word proportional pops up. So keyword already circled here, proportional. So the graph shows a proportional relationship between the number of hours a factory is in operation and the number of gallons of water that's used here. What we need to figure out is whether or not each of these statements here are true or false. So this is all about reading a graph and making sure that we know the information that's provided to us is either true or false. So the first point here says the factory uses 4 gallons of water when it is in operation for 4,000 hours. So how do I consider whether or not this is true or false? I found 4 gallons on my map here. So 4 gallons of water would be somewhere down here. Boop. So remember, careful of your label. So it says 4 gallons here is in operation for 4,000 hours. Now here is where they're trying to trick you, because it looks like to me that they switched these two labels around. So moral of the story here is labels are important. Don't let them trick you. So this is a false statement. So if it said 4 hours for 4,000 gallons, this would be a true statement for sure. The second thing says point W represents the number of gallons of water used when the factory is in operation for 7 hours. So point W is here. Let's verify the information. So it looks like it represents 7 hours, and it's at about halfway between 8,000 and 6,000 there on my graph. So this one checks out. Definitely, definitely, definitely a true statement. Third statement here, let's see where this is on my graph. It says the factory uses 9,000 gallons of water when it is in operation for 9 hours. So I find 9 hours on my graph here. I walk up to my line and I see if it also verifies at 9,000. Yes, so it's about halfway between 8 and 10, which would be 9,000 gallons, which would also be a true statement. So this one, not really a lot of math here, more about reading a graph. So just make sure that you're careful with the labels and you will be just fine on problems like this. All right, so this one is our composite area, and this is definitely something that we've covered. And in this case, it says the figure shown is created by joining two rectangles. Enter the area in square inches of the figure. So biggest thing that pops out to me is rectangles. So what I know I'm going to break this shape into is to two different rectangles, and you should probably see visually that these are the two rectangles that I'm looking for. So if I want to try and find the area of two rectangles, all you need to remember is that area is just base times height, and we've got base times height for both of these different rectangles. So first multiplication for this big rectangle would be 75 inches times 15 inches. So if I do 75 times 15, and again, make use of the calculator function if it is available to you. So 5 times 5 gives me 25. 7 times 5 gives me 35, plus 2 gives me 37. Moving on to the 1, so 0 in the placeholder. 1 times 5 gives me 5. 7 times 1 gives me 7. Do a little bit of addition here. I get 5 plus 0 gives me 5. 7 plus 5 gives me 12. And last but not least, 7 plus 4 gives me 11 here. So this would be in total 1,125 inches squared. For the smaller rectangle, I see that my base here is 25 and my height here is 10. So 25 times 10 is a little bit of an easier multiplication here. Would give me 250 square inches. So my final answer, which I'm not going to finish for you here because you should know where to go from here, is once I find these two areas, all I gotta do is add them together to get my total area in square inches. And this, just like anything, is just a composite area type of problem. This problem here, I would like to call the hack problem. Now, why I'm calling this the hack problem is because I'm going to show you a sweet hack to make sure that you understand how I got to the correct answer here. Now, reading through the scenario, it says Alfonso went to Sam's famous appliance store, or famous Sam's appliance store, and purchased a refrigerator and stove. It says the sales price of the refrigerator was 40% off the original, and the sales price of the stove was 20% off the original. It says which statement must be true to conclude that Alfonso received a 30% overall discount on the refrigerator. Now, what I see stands out is that there's 3 percentages. Now, what I'm missing from this problem is I'm missing the original price of each of these objects. So I'm purchasing a refrigerator and stove. So looking through the answer choices, it says the sales price of the refrigerator and stove are the same, or the original prices of the refrigerator and the stove are the same. It looks like what I'm trying to figure out is whether or not the prices were the same or if they were different. So if I can figure out if one of these things are true, then I can give myself a 50-50 shot just by process of elimination. So here's my thinking through this problem. If I'm taking a percentage of something, I think the easiest thing to take a percentage of would be 100. So let's pretend the refrigerator is worth 100 and the stove is also worth 100. Why? Because it's just an easy number to take a percentage of. So if I know that the refrigerator was 40% off, that means that I took off $40 from the original price and I paid $60 for the refrigerator. Not a bad deal. Using similar reasoning, if I took 20% from the stove, that means I subtracted $20 from it and I paid $80 for the stove. In total, in red here, I paid a grand total of $140 for both of these items. Now that I know how much I spent originally, what the question's asking me to figure out is this equal to a 30% overall discount? Now, overall means that since they were both worth $100 each, if I were to spend that original $200 on both of those things without any sales applied, and I took 30% off, so I multiplied this by 30% or 0.30, would I get the same result, which is paying $140? So doing a quick calculation on either a calculator or doing the long multiplication, 200 times 0.30 gives me 60. And if this is how much I take off, that means that I would spend 200 minus the $60 in my discount, which would give me $140. So here's what this tells me. A whole lot of work tells me one thing and one thing only, that the original prices of the refrigerators were exactly the same because we made both of them worth $100. Now here is my serious advice for a problem like this. This problem here not only would take a lot of time for you to do, but it would also take a whole lot of critical thinking. So in the scheme of the test, I would skip over it and wait until the very end that you had more time to review your answers and try your best to answer it the best that you can. For me, this is just an overcomplicated way to ask you a few things, but my hack here is if it's ever asking you for a percentage, use 100 as the original price because it's the easiest thing to take a percentage of. So definitely hack your way through a problem like this. It's not the cleanest problem in the world, but you should definitely take advantage of some of these strategies. Last problem for the review comes in our old friend, the word proportional here. So first thing that I'm going to box up is this word proportional. And if you remember from all the problems that had this word in it, proportional means nothing more, nothing less than creating a fraction in which we're comparing things to. So it says select all the tables that represent the proportional relationship between x and y. All is also an important word, which means that there could be more than one correct answer here. Now what we need to figure out is if we create a proportion between x and y, is it going to be equal in every single entry in the table? So if I take, for example, my last table here, and I'm skipping to the end, if I were to create some fractions with these numbers, so if I took 1 and 5 and I made a fraction, and I took 3 and 15 and I made a fraction, and 4 and 20 and I made a fraction, are these fractions actually equal to each other? Because if they are, that means that it's proportional. So 1 over 5 can't be reduced, so I boxed that one. 3 over 15 can be reduced to 1 over 5. They're equal. 4 over 20 can be reduced to 1 over 5. So confirming that all three of these proportions are equal means that this table represents a proportional relationship. Now, if we have two things that are fractions, don't be scared here because we know how to divide fractions. So for instance, in this top table here, I see I have 1/5 all over 1/10. Another way to write this down would be 1/5 using the division symbol divided by 1/10. And what we remember from dividing fractions is it's all about keep, change, flip. So I'm going to rewrite this problem as 1/5. I keep the first fraction the same. I change the division to multiplication, and I flip the second fraction. Carrying this multiplication out, I get 10 over 5, which gives me 2. Now all I would have to do is verify that each and every other entry in this table would also be equal to 2 when I divided them. So this is your approach when you are doing anything for proportions using tables, and this is your quick tip to make sure that you're able to verify that proportional relationship. For sake of completeness here, you would verify that the first one also checks out. So once you do the division for all those different entries, you would get 2 as your answer as well. These ones do not work, so you do have 2 correct answers for this last problem here. Good job, you made it. This brings us to the end of practice part 2. We're going to continue to practice over this next couple of days and into Monday before you take this test, just to set you up for the most successful testing experience possible. So just gain some confidence in the types of questions you'll see. I think even besides the math, just getting exposure to the types of questions that you could see is very, very, very helpful. So just again, read your way really carefully through these types of questions, use what you know, and just trust your instincts and do your best. So thanks for listening, and until next time, I'm your boy, Mr. Uy.